Okay, good morning to all. Myself, Selvaprakash, working as assistant professor in chemical engineering department at Erode Sengunthar Engineering College. First of all, I'm happily welcome to you all at the AICTE presented PRERANA, a program which is conducted by AICTE. It is only for the preparing SC students for higher education, which means GATE. Now, in this session, we are going to discuss about the subject chemical reaction engineering, which is the topic is in this chemical reaction engineering. We are going to specifically see the continuous stirred tank reactor, which denoted as the CSTR. Okay, what is meant by CSTR? Basically, we are generally know about the kind of steps like CSTR means it's a continuous steroid, which means the stirrer or steroid aggregated vessels like some equipments used in the reactor. These kind of things are called as the steroid. Okay, so we all know continuous steroid tag. This is uh, actually in this CRE topic. Basically, we need to know about the types of reactors, which means uh, continuous tank reactor and a semi-batch reactor and batch reactor like that stuff. In this types of reactor, tank model reactor is one of the major reactor type. Okay, for that we can use the continuous stirred tank reactor. Okay, this is the simplification and the simple notes of the CSTR. Okay, now we are going to briefly discuss about the continuous stirred tank reactor kinetics and what are the steps used in this reactor, how the designs are performed, and what are the operating conditions, how they choose this reactor, like the of kinds we are going to see in this. First of all, we have to know about the what are the types used in the continuous stirred tank reactor. Basically, mainly continuous stirred tank reactor is the one of the type. Okay, in this continuous stirred tank reactor, we have some uh, sub subtitles, which is how I tell that subheadings. Subheadings. Okay, in CSTR, we mainly focus on the what is the design basis. What is the design basis for CSTR? And next one is what are the major kinetics? What are the major kinetics used in the CSTR reactor? And finally, what are the classifications in the chemical reactors? Okay. Before that, you all know about the generally what are the types of reactors used in the chemical industries. Okay. First, I have to tell that major three types of reactors which is used in the chemical industries. Okay, the first one is batch reactor, second one is semi-batch reactor, and the third one is continuous reactor. Okay, uh, in continuous reactor, the process which is the reaction. Okay, the reaction is continuously running by the industry. Which means we are going to produce the ammonia means the nitrogen and hydrogen feed continuously given to the reactor, and finally our product ammonia is coming. This process is obtained by the continuous phase. Okay, so that we can call as the continuous tank reactor. At the after the next one is semi-batch reactor. Wait, before that we have you have to know about the batch reactors. Okay. Batch reactor means same process. We give the feed to the reactor and the product automatically come to the exit point. Okay, the simple phenomena. For the you all know about the basic time interval. The basic time interval keep in the case of the batch reactor. Okay, which is example we can give the 1 hour time interval. Okay, so consider as a reactor. The feed was here. The feeding. The feeding. What is our feed here? Hydrogen and nitrogen. Okay, the hydrogen and the nitrogen are feed into the reactor. In that reactor, we give the 1 hour time for the reacting. For the reacting, we have to there is some molecular interactions and the product is converting to the intermediate phase or intermediates and then converted into the radius and then they are converted into the product. Okay, finally they are converted into the product. For that, the reactor needed time. Okay, in that time we give the feed and extra like the catalytic and like the things. Okay. The what is the third type of the reactor or process types is semi-batch reactor. Basically, the semi-batch reactor is one of the basic and simple type which is used as the most of the industries. Okay, what is the semi-batch reactor? The semi-batch reactor is nothing but the combination of continuous and batch reactor is the semi-batch reactor, which means we can use the continuous reactor or we can use as the batch reactor and mainly in the semi-batch reactor that which is the periodic time interval. Okay, that periodic time interval is mostly used in the semi-batch reactor. Okay, okay. So these are the basics of the chemical process types or chemical reactor types. What are the what is this? The first one is continuous. The second one is semi-batch. The third one is batch. For my convenience, I told you that semi-batch reactor as the second one. You can verify the books or some web pages in this. They are put into the batch reactor as the second one. Okay, that means that's the three types. Basically, there are three types in it. We have to understand that. Okay, whatever it is, we have to understand and apply the understanding concept after that the practical knowledge which is mainly used for the engineering field is developed. Okay. Okay. Okay, now come to the topic continuous stirred tank reactor. I already told that continuous stirred tank reactor is the one of the mainly reactor which is mostly used by the industries. Okay. Okay. In the continuous stirred tank reactor, there are some factors. Okay, there are some elements which directly affect the reactor performance, which is the rate, which is the rate. Rate means what is the measurement. Okay, what is the measurement used as to measure the chemical reactions is called the rate of the reaction. Okay, the rate of the reaction is nothing how the reactor performs, or else what is the speed of the chemical reactor. Okay, how how much time was taken by the reactor. That is the simply known as the rate or rate of the reaction. Okay. In the rate of the reactions, we have some factors that affecting the rate of the reaction. Okay. What are the first one is temperature. Okay. Temperature. In the temperature, how the temperature affect the rate of the reaction means, which is we already generally know about the all kind of this lower temperature and higher temperature things. So that according to our operating conditions, we have to maintain the temperature, or else the reaction is collapsed. Okay, that is the major one. And then automatically, if the temperature comes means automatically, then the second thing by comes our mind is pressure. The next one is pressure. So what is meant by pressure? How does this pressure affect the reactor? Simply, simply we all know about the how what is the feed, what is the feed given, and how much of the pressure applied in the reactor while transferring the feed into the reactor. Okay, this is the major part of it. Okay, now the next one is what is the feed nature. I hope you all understand that feed nature means how can I tell you? Okay, listen. The feed in nature is one of the major rate affecting factor, because the why I am telling this is according to the feed natures, the whole reaction is getting collapsed, or yeah, the basic phenomena is only used for the reactors or in the reaction purpose, which is only they if there is any small changes in it, they are going to directly affect the chemical reactions. And can what is the product? How can I tell you that they are going to directly affect the product only. Okay, in our terms, we are going to concentrate only in the profit terms. So automatically, if the profit means there is a product and there is a quantity of product, and what is the quality of products is automatically come by it. Okay. For that, feed nature is major one. Feed nature means what is the feed nature? Basically, we all know about the like that liquid type feed, jelly, jelly type feed, semi. Sorry for that. Or else we all know about the semi-liquid feed like that ones. Okay, feed nature, and automatically we are going to discuss about the small subtopic in this is catalytic. Okay, how the catalytics are used in the reactors, and how they are performed in the reactions, and then how they are going to affect the rate of the reactions. Okay. Catalytic is one of the main terms used as to boost up the chemical reactions. Okay, so for that majorly there is no negative in the catalytic reactor types. Sorry, the catalytic reactor type means the reactors which is used by the reactors. Okay, okay. These are the factors affecting the reactors. Okay, and as I told you before that, you all know about the types of the reactors, and what is the chemical reactor reaction, and how they are performed. What are the basic operating conditions given by the industries or manufacturer. Okay, the next one is automatically we are going to confine the where chemical reactions takes place. Okay. In this slide we are going, you can see in the second box of the content, confine where chemical reactions takes place. Okay. Okay, simply we are know about in reactors. So in that reactor, if we give the feed into the reactor at the time in the reactor, all the feeds are going to settle in the corner or bottom of the reactor. How the reactor or else how the reactions performs perfectly. You can think it. Okay, what if our feed is going to settle in the corner of the reactor or else bottom of the reactor? How the reactor is going to work perfectly? That is our question. For that only we can use a device. So which the device is used to agitate, means agitated. Okay, agitated the feed, or else you can simply say that stirred. Okay, stirred things. For the time the a device which can used for the complete mixing, or else the thorough mixing of the feed into the reactor is naturally concentrated in the continuous sterile tank reactors. Okay. Okay. The next one is majorly we are going to talk about this size parameters, which is I can simply explain that in the basic manner. Okay, with the way. What is the basic manner? What is that means? Consider a reactor which contains a 100 kg storage. Okay, so just leave the area, length, volume like this kind of things. You just assume that 100 kg of the feed is stored into the reactor. Okay. Our operating condition is 95 kg, 95 kg per hour. In the time, at the time, what we are going to do is the major things that is used for the rate of the reaction. Okay. So what we are going to do is we have to there is some we have to do some changes in the reactor, or else you can assume that we can consume only 95 kgs if the problem is that is going to not. What is mean by which is the perfect chemical reactor is non-changeable, which means we don't change the length of the reactor or volume of the reactor or wide of the reactor or height of the reactor, like kind of things. If the industry placed a reactor in the place, okay, once it does not, sorry, it does not change for an decade, okay, or 100 years. This is the basic concept which is used to all the industries, which is used by all the industries. Okay. We have to consider the size parameters as well as in the first very beginning. Okay. Okay. The reactors are this is the basic definitions. Okay. You all know about this in the school level. The first one is classification of reactions. Okay. Phase we can classify the chemical reactions by using the phase of the reactor and the reversibility, which means the reaction is irreversible or reversible. Okay. And then molecularity, which is how many molecules are used in the reactor. Okay. So okay. Now we are going to see in this. The first one is phase. According to this, there is a two reactions here. The one is homogeneous reactor, heterogeneous reactor. You guys already know about homogeneous and heterogeneous. Homo means the same kind of nature things are used in this reactor. Hetero means there is a different kind of uh, feed natures or nature of the material are used, which means a liquid, that means gas, liquid gas, like kind of this. Examples are used in the homo and heterogeneous reactions. Okay. The irreversible and reversible reactions. So yeah, normally we all know about the reaction is basically the feed is converted into the product, which is normal reactions. Okay, that is irreversible. Okay, reversible means which the product is converted into the feed. Like how funny is this? Not at all this. You have to concentrate in the how we are going to convert into the product, and the next one is how we are going to convert into the feed from the product. Okay, this is the basics information you have to know about it. And then last one is molecularity. According to the molecularity, there is a unimolecular, a bimolecular, heteromolecular. These are the basic kinds. You can just understand by watching the slide. Okay, on the listen the slide. Okay, in first one unimolecular, which means A feed gives into B gives the feed product. Okay, and bimolecular means A B. Okay, two molecules give the C product. And the last one is the third one is tri thermonuclear reaction, which means that 2A. Okay, carefully look into the slide. 2A. Now you can question about it. What is the 2A? What if happened I use the C as the third molecule, sorry, third molecule. What will happen? Nothing will happen. You can use it. Okay, whatever we have to add or subtract in the reactors, we can make it. Our ultimate aim is we have to produce the maximum efficiency of the products and which is converted into the maximum level of profits. Okay. This is the only all the industries want. Okay, you can use it as 2A or 2B or 3C things. Okay. The only the only thing you have to concentrate in it is the molecules number of molecules used. First, unimolecular one molecules are used. Bimolecular two molecules are used. Thermolecular three molecules are used. Okay. Okay. According to this, which means according to other chemical reactions and the rate of the reactions, we are going to use in the a basic reactions. Okay, A molecule and the small a is the number of moles and capital A is our feed. Okay. Like similarly, small b is the number of moles we used, and automatically the capital B denotes the B as the capital B as the feed, which A and B converted into the C and D products. Okay, C is the number of C molecules in each. The capital C is the number of C molecule. Okay, which is denoted only the molecules, just molecules. Uh, After that, before that we are going to study about the rate of the reactions. You have to understand what is the rate. Okay, already in the previous slide I told you literally, but in it you are going to see about the definition of the rate of reaction. Okay, rate of reaction is nothing but change of the concentration with respect to time is the simple one. Rate of reaction is change of concentration with respect to time is the measure. This is the definition of rate of reactions. Okay. Sorry. Okay. The rate equation. The rate equation, you already know about the rate equation. Means there is an equation which are going to analyze the rate equation is nothing. It is an equation which is going to analyze the properties of reacting material, reacting conditions, and including species, temperature, pressure, or type of the catalytic, if any, at point in this system. This is the proper definition of the rate of reaction. Okay. The previous sentence is basically basic kind of steps, and the second point is which is denoted in the dark blue color. That is the one definition of the rate equation. Okay. Okay. Now you can literally understand the rate reaction terms. Oh, after that, the rate equation, if there is a one thing in which you all know about the cases are dependent or independent. As like humans, humans are dependent or independent. Like like that, we have to analyze the reaction rate, which is independent or dependent. Okay, for that you can easily understand reaction rate is the independent of reactor type. Okay, which does not consider the reactor type. Okay. Now, okay. Now, what are the terms affect the rate equations? In previously, we already studied in the temperature, pressure, concentration. Like this kind of stuffs are only affect the rate equation. Okay. In mathematically, it can be represented as the R, small r equal to small k into capital T, temperature, function of F of concentration of A and B, which is two molecules are used, or else the reaction is simply defined as the bimolecular reaction. Okay. In this term, you can question about it. What is meant by K? A is nothing. This is the constant. Small k is the constant term. Okay. Uh, After the class, upcoming classes, sorry, upcoming in the upcoming classes, I can explain it. Okay. Okay. What is the unit of the rate equation? In the dimensions, mole divided by time into length cube. Okay. Or else converted into the units, SI units, mole divided by time is converted. Here is denoted as the S. Length is denoted as the meter. The meter it denoted as the small m. The cube automatically come into this slide. Okay. The next one is we are going to study about the what is the factors which is affect the rate equation. Okay. The basic terms which is used as the in it is automatically previously I told the temperature, the pressure, and the feed condition, which is sorry, feed nature. We can simply know as the feed nature. Feed nature, and then concentration on the reactants and the catalytic reactions. Okay. Now, in previously, as I told, consider a reaction is shown in the slide. It is defined as that each species of the chemical reaction, that is RA is negative, or B is negative, or C is positive, or D is positive. What is meant by RA, RB, RC, RD? You guys, you can question it. What is meant by RA, RB, RC, like that? For that, we can write the rate equation for every molecules. Okay, which is A molecular, or else B molecular, or else C molecular, or else D molecular. Sorry. Okay. RA is the rate of reaction, rate of A reaction, or rate of A reactant. Okay. And what is meant by the negative positive terms? What is mean by negative positive? What does mean? Okay. Simply, you guys know about this. The main feed, the main feed is converted into the product, which is there is a energy transformation happened from which to which feed to product. Okay, here what is the feed terms? Automatically A and B. What is the product term? C and D. Okay. So you can cross verify them. You can cross verify what I told. The energy transformation which is transferred into the feed to product. Now the energy transformation. What is the energy? The energy was transferred into the B from sorry, the energy was transferred into the C from A and B. Okay, there is an energy loss happened in the feed. Okay, there is an energy gain in the product. So that only they write us like that RA negative, RB negative, RC positive, RD positive. Okay, now you already know about the stoichiometric ratios, which means the rate equation of stoichiometric ratio of the stoichiometric is nothing. Okay, what is the rate of the reaction, which is already you guys know about it, or that one is the rate of the reaction, and simply divided by the number of moles used in the reactor. Sorry, in that reaction, which means consider the A. Okay. Number of moles, number of A moles used in the reactor. Okay, you can say it in this slide, RA divided by A. As I told, RA is the rate of the reaction divided by A is the number of moles used. Okay, so similarly, you can write it for B and C and D. So in it, how they are equal, how they putting the equal symbol in it is the main term we are going to see in it. Okay. The reaction rate can be obtained by experimentally. Yeah, we now still know what are the terms we are discussed in it. Rightly recall it. Tank reactor, reactor tank reactor. What is the process like? The kind of structs we used to discussed in this session. Okay. According to this, consider the sections. These are the theoretical terms, which means they are does not proven by the experimental, but the rate reaction can be only obtained by experimentally. You have to you have to make a terms You have to make a terms that which is converted into the feed to product. Okay, in the slide. Before that, I'm going to tell about the charcometric ratio and the number of modes in used it. How they put the equal symbol in it. According to us, feed converted into the product. Okay, according to us, the feed is converted into the product. What happened in it? The energy loss and the energy gain. According to there is irreversible reactions. So automatically A and B are equal, and we can use it. C and D are equal. Okay. Now what terms are used to? What are the terms are used to confine the feed and the product are equal? In the in these terms, automatically there is an energy loss happened in the feed. Okay. And as usual, similarly, there is an energy gain happened in the product. For that, the stoichiometric ratio of the following reactions are automatically comes as equal for all the reactions. This is the next slide. In this slide, we are going to discuss about one problem. Example one. As you have to listen carefully, read the question by yourself, or else I am going to read it. Okay, listen. Nitrogen oxide is oxidized to nitrogen dioxide. Okay, according to the following stoichiometric equation. Once again, I am going to read it. Nitrogen oxide is oxidized to nitrogen dioxide, which is simply you guys know about that. That is an oxidation process happened in the reactor. Okay. The stoichiometric equation. The stoichiometric equation is 2 capital N capital O plus capital O 2. Okay. So gives 2 N O 2. Okay. This is the stoichiometric equation. If the rate of nitrogen dioxide was measured and found to be 4.0 moles per meter cube per second, you guys remember the unit of the rate equation. Okay, mole per meter square per second. Okay, you can compare in it. Okay, moles divided by time and one second. Okay, so you guys compare it. Okay, moles divided by time into length cube. Or similarly, the unit was given mole divided by meter cube per second. What it would be the rate of the two other species? Okay, in it, the nitrogen dioxide rate was given. Okay, for nitrogen oxide and oxygen, we have to find the rate. Okay. Now the solution is reaction rate models. you can easily look at look at the sun. The nitrogen, our nitrogen dioxide is the product. Okay, so we are going to analyze it. There is a small changes in it. What is it means? That nitrogen dioxide was converted into the oxygen and a nitrogen. So the two terms means the two elements are used in the reactor. So overall the rate equation value is 4.0. In the feed side there is a two um, elements are used. Automatically the 4 is going to divided by 2, the 2.2. So the rate of the two other species is 2, which means 2.0 moles per meter cube per second. Okay, this is the simple sum. You can guys are know about the basic terms. We can easily approach it. Okay, now we are going to study about the reaction rate models. Okay. Reaction rate models means there is some models. Okay, there is some defined models are used to measure the rate of the reaction. Okay, the first one is power law model, and the second one is complex law model. Okay, the simple equation for the power law model, the simple equation AB plus BB plus CC plus DB. This equation is going to converted into the rate equation. We are yeah, the guys already know about the small RA is a rate equation denominator, denominator value RA, and the minus sign is going to represent the energy loss which is happened in the feed side. Okay, the rate of the reaction are equal to the rate constant as the as previously we told K is the rate constant and the A is the A. The A represents the A molecule. Okay, and Ca represents the concentration of the A molecule, and Cb represents the concentration of the B molecule. Okay. So simply, I am going to explain by using the sentence. Okay, the product, the concentration of the product, which is automatically equal to the individual reacting molecules. That's it. The concentration of the product are automatically equal to the individual reacting molecules concentration. Okay, this is the power law model, and these are the basic things you have to know in it. Okay, the unit of the specific rate equation. Sorry, before that you have to know about the complex rate model, the side one, or else the second one. Okay, second one, the same changes that we have to analyze the rate constant for product and the feed, and we have to convert into the product into feed and the feed into product. That's a reversible reaction. They does not represent in the slide. For that you can easily find out in the web page, in the web, or by some using textbooks. The basic in irreversible reactions, we use power law models. For the reversible reactions, we use complex rate models. Okay. Okay. And finally, we are going to discuss about the specific reaction rate, which is K. K, K is nothing how a molecule is converted into the products. So how the feed molecules are converted into the product molecules according to given time or operating time. Like power 1 minus n is n is the number of orders. Number of orders is alpha plus beta. The alpha plus beta terms are nothing. They are the basic terms which comes from the power law constants. Power law model constants. Okay. Reaction rates are determined by experimental observations only. This is the literature. Sorry, this is literally we can use it by some designs and kinetic processes. Okay. As I told previously, there are three types in the types of reactor. The first one is batch reactor. Batch reactor are defined as reactors which no flow of mass across reactor boundaries once the reactant has charged. Okay. This is the psychometric representation of the batch reactors. See in the definition for batch reactor. Batch reactors are defined as the reactors which no flow of mass, which means uh, the feed inside the reactor, there is no changes or no oscillations. This is batch. If once the was fed, feed the feed was fed into the reactor and the reactor's valves are closed. After the 1 hour or time, how much time we need the operating time. Okay. After that 1 hour, the reactor is going to open. Before that, there is no disturbance in the reactor. This is the some advantage and the disadvantages of the batch reactor. Okay. The batch reactor there is a few advantage and disadvantages here. The basic advantages of the batch reactor is mainly in the batch reactor there is a product efficiency. There is a maximum product efficiency. It does not touch by using the conventional reactor or a semi-batch reactor. Batch reactor is one of the finest method which is used to top products, which means top quality products. Okay, this is the psychometric representation. Right? This is the diagram for the batch reactor. You guys already know about the this is the tank. Our tank setup is automatically comes from the if once there is a word reactor or reaction tank vessel. Don't worry about this all kind of stuff. Automatically put the fire and named as the tank. This is the simple one. You can use this tank okay, when they are asked as vessel or else a reactor or else the or some kind of things. Okay. There is still used to uniform mixing, and this is the liquid surface, the topmost level. Next one, mode of the operations. In the batch reactors, there is a five mode of operations. This is- Sorry, the first one is cleaning the reactor. This is the basic one. If you need perfect quantity and quality of product, you must clean the reactors perfectly during time intervals. Okay. Okay. The next one is loading the reactor. Loading the reactor in this mode, the feed are going to given sorry in this simply we are going to load it into the reactor which feed. Okay. The final sorry the middle one is adding the indicator. Adding the indicator means we have to analyze the measurement. We have to analyze the speed of the reactor. For that, we have to make some data so that only we have to mark the some data t equal to 0. And the second one is stopping the operation, the final part of the operation. And the last one is unloading the reactor, which means product collecting. In this case, we are going to clean the reactor and they get to a product. After that, the quality controls analyze the blah blah structure that is not in this part. Upcoming classes we are going to see. This is the major 7 points or basically characterizes the batch reactor. Okay. Each batch reactor or each batch process is closed system. The next one. The total mass of each batch is fixed. The total mass of each batch is fixed, and the volume or density of the each batch may vary as reaction process. Okay, the volume or density of the each batch may vary as reaction process. And the fourth one is the energy of the each batch may vary as the reaction process. If it changes, may be provided to control temperatures. The fifth point is the reaction time or the residence time on the elements of reacting fluid is the same. The reacting time is same for the reacting fluid. Okay. The sixth one, the last one, the last two. Okay. The sixth one is the operation of the reactor is unsteady state. Okay, this one is closed system and the fixed. The total mass is fixed, and finally in this is unsteady state and batch composition changes with respect to time. Batch composition changes with respect to time. Okay. At the time, the batch is uniform in composition, temperature, because of the efficient and the stirring methods. Because you can see it in the reactor, this diagram, there is a stirrer used. What is the purpose of the stirrer? It means look at the seventh one at this time. At the time, in the batch process, there is a mixing. There is a complete mixing, composition, and the temperature because of the efficient. Because we all know the product efficient. Okay, so that only we are going to consider the major terms. Okay, so this is the basic part in this class. Okay, already I told in the subject chemical reaction engineering topic which is CSTR. Okay, continuous sterile tank reactors are designed to be followed by characteristic the intensive mixing, intensive mixing, so that the properties here inside the reactors are exactly the same as the exit stream. This is the diagram for the CSTR. Simply, the input and output terms are added in the tank reactor. This model can be also used as a wet catalytic powder, that is fluidized wet reactor, slurry bubble column reactor, slurry bubble column reactor, and polymerization reactions. Okay, so like like the batch reactors, there is some characteristics are used into the continuous sterile tank reactors. What are this? I am going to explain it. The first one is the flow through the vessel, both input and output is continuous, but not necessarily at a constant rate. Okay. The second one is the system mass inside each vessel is not necessarily fixed. Now you guys remember the batch reactors first one. Each vessels are constant. For the batch, for the continuous reactors, inside inside each vessel is not necessary to fix it. And the volume and density of the each batch may vary as reaction process. The energy the energy of each batch may vary as reaction process. Heat may be provided to control temperature. And the fifth point is the reaction time for elements of the reacting fluid is the same. And the last one is the operating condition. The operation of the reactor may be steady state or unsteady state. The fluid property are uniform composition, temperature, anywhere in the vessel because of the efficient and the stirring. Okay, this is the plug flow reactor, which is the semi-batch reactor. Plug flow reactors are defined to follow reactors characterized by the absence of mixing in the direction of flow and absence of variations normal to the direction of flow. Okay, diagram. This is the plug flow reactor diagram. This model can be used to model a tubular type reactors, such as I told in the previously example types, tubular tank reactors, such as ammonia manufacturing reactor. This is the plug flow reactor characteristics. The first one is the flow through the vessel with input and output streams continuously, but not necessarily at the constant rate. We was just listening it. This characteristics, which is plug reactor characteristics and continuous sterile tank characteristics, are mostly similar, but there is a